Beatles 28, you are clear for takeoff.
Knots. Stop! Don't hammer the brakes. Don't hammer the brakes.
137 people are on board this British Air Tours flight. Within minutes, nearly half of them will be dead.
This should not really have happened.
Evacuate! Evacuate!
The aircraft didn't even get airborne. It didn't run off the runway, and yet still 55 people were killed.
For investigators, it's a familiar routine. Reconstructing the final moments inside the cabin, analyzing the wreckage and the flight data recorders. In the end, they turn to a psychologist to help them figure out how a survivable emergency turned into one of British aviation's most horrific disasters. It's just before 6 in the morning on August the 22nd, 1985. Manchester's airport is coming to life. The first flights of the day are being prepped for departure. British Air Tours Flight 28 is scheduled to take 131 passengers from Manchester to the Greek island of Corfu. British Air Tours is a division of British Airways, specializing in low-cost flights to vacation destinations. It's a chilly morning. A slight breeze is blowing, ideal flying weather. Most of the passengers on this early morning flight are traveling on vacation. Lindsay Davis is heading to Greece with her boyfriend, Charlie Thixon.
All right, let's go.
We'd been going out with each other for a year, and that's one of the reasons we were so excited about it. You know, it was our first holiday together.
Captain Peter Terrington is in command.
I was the senior training captain on the fleet.
First Officer Brian Love is being trained by Terrington.
He was going to perform the takeoff and landing as part of his training.
All right, Captain? Yep. Briefing then, Brian. Airfield emergencies, you handling the aircraft. What are the 4 things you're going to stop for?
Fire, failure, configuration warning, or you shouting stop.
Okay, so you bring the thing to a stop, and I'll take over the aircraft and leave you to deal with the emergency. I'll liaise with ATC, okay?
If you've talked about the possibility of an emergency and talked over what you will do, then if it actually happens, it's easier to recall those items.
Okay, Brian, start 2.
Starting 2. Oil pressure rising.
Okay, go on.
25, 26, 27, 28, 29. 129 plus 2 on board, Captain. All strapped in, doors are closed down automatically.
Thank you, Arthur.
The crew is flying a Boeing 737. It takes just 4 minutes for the plane to reach the foot of the runway.
Beatles 28, you are clear for takeoff.
The 737 has 3,000 meters to get to takeoff speed. The engines are pushed to high power.
I was sitting by the window, looking out of the window. Everything was normal. The plane was going quite fast.
80 knots.
Check.
We heard a dull thud, which sounded as if it came from outside. I was really keen to see what was going on outside, but couldn't see anything.
Captain Terrington needs to act fast.
Stop!
And the immediate reaction was to stop. We were quite a few knots below our decision speed, so I very quickly closed the throttles and applied reverse thrust.
We could feel the aircraft slowing down, and Arthur said, "Oh, I think we've blown a tyre," and I didn't know, so we just waited to hear it.
Don't hammer the brakes. Don't hammer the brakes.
I thought the tyre might have gone and would cause some damage to the undercarriage if we braked too strongly.
Probably nothing. I wouldn't worry.
And just assumed that maybe a tyre had burst, so I wasn't really alarmed at that point. My thought at that time was, oh, OK, we're going to get off this plane and probably have to move all the luggage onto another plane and take off.
Soon, passengers on the left side of the plane see the real problem.
I could see orange flames inside the back of the engine. And at that point, I thought, it's obviously not a burst tyre, that wouldn't cause that, and this is perhaps something a bit more serious.
Let me by. I'm not staying there.
But at that point, I knew that I wanted to get off the plane, and I wasn't happy at all. I knew that there was a fire, and I just wanted to get away from the fire.
Smoke is seeping into the cabin.
Please sit down.
My nearest exit was at the back. I didn't want to go to the back because the smoke was coming in there. So I decided in my mind that I was going to go through the front. I said to Charlie,
On, we're going.
and that's when I started going towards the front of the plane.
Stop it. 28 Mike, we are abandoning takeoff. Looks like we've got a fire on number 1.
Looks like there's a lot of fire.
Thank you.
Plane on fire, runway 24.
From where he's sitting, Captain Terrington can't see how bad the fire is. He needs advice from the tower.
We have to get the passengers off.
I would do by the starboard side.
Terrington decides to pull off the runway.
Evacuate to the starboard side, please. Fire drill, engine number 1. Shutting down 2.
Evacuate! Evacuate! Please stay calm!
Before the flight crew leaves the cockpit, they must complete a 15-step checklist.
Parking brake.
Set.
Speed brake lever.
Down.
But time is running out.
We had an evacuation checklist, but it was 4 pages long, and the last item was to get the passengers off.
Engine and APU fire warning switches.
This didn't cover my problem at all.
On the 737, there are 4 cabin doors. The 2 in the back are covered in flames and smoke, leaving only 2 for 137 people. Then, a mechanical problem eliminates one of those.
Well, Arthur was opening one right, and he was really it was really trying to open. It was really hard to open.
The back of the cabin is filling with smoke. It's making breathing difficult. Passengers rush forward.
It just seemed to go on forever before they started evacuating. And that's when I thought, I'm not going to get off, it's going to blow up with all of us on it.
Engine and APU fire warning switches.
Right now, all 137 people on board are alive. But with every second, their odds of surviving are decreasing. Flight 28 is becoming a death trap. The jammed door on the right side of British Air Tours Flight 28 leaves the crew no choice. They must get the passengers out from the side of the plane that's burning.
It soon as we opened the door, the fire service were already around, shooting foam up the slide and came into the galley floor. We wanted to start to evacuate the passengers, but there's a bit of a bottleneck and nobody was coming forward. The aisle is quite narrow where the galley is, and they were and then they were pushing forward, and I could see this boy that was really sort of pushed against the wall. He couldn't get out, so I pulled him by his T-shirt, had the yellow T-shirt on, and he sort of tumbled forward, and after that, everybody sort of just tumbled in behind him. And we just directed him down the slide. In training, they tell you to, bring people to the door and you tell them to jump.
Desperate to get people off the plane quickly, the purser returns to the jammed door. After several attempts, he manages to force it open.
The only time I turned around was to make sure that Charlie was following me.
See you out there.
One thing I did see when I looked back was people going to the front, towards the front of the plane where the seats are, and pushing the seats forward, folding them down as they went along. So people were trying to rush forward from the back. The chute was open and people were just jumping up straight onto the chute. As I got to the bottom, I didn't look back at all. I was just wanting to get off.
Dozens of passengers have made it off the plane, but there are still many more inside.
But it was smouldering and it was black, thick black smoke. And Charlie had said that after you'd gone, this black smoke came down, he said, and everybody was screaming and panicking. He said people are going to die in there.
Standby power switch.
Captain Peter Terrington and his first officer, Brian Love, are still aboard the burning airplane, and they still haven't completed the steps required to evacuate.
There was 4 tons of fuel coming out of that aircraft wing tank.
Okay, go, Brian. Go, Brian.
I could see quite a lot of flames.
Completing the checklist would put their lives at risk.
We did as many items as we could, and then we both went out of the flight deck window.
There are no more passengers at the exits, so Joanna Toff decides to see if anyone else is left in the cabin.
And the smoke was you could touch it. It was so thick, and you could take it was awful, really.
Go.
There was a young girl just a bit further down in the cabin, but she was really disorientated. I mean, I suppose we all were, really. We just didn't have any idea what was going on. I just brought her down to the slide. She was taken off then. The fireman was telling me to come on, and I was thinking, well, I've not finished, we've not finished yet.
When Toff re-enters the cabin, the thick smoke makes it as hard to see as it is to breathe.
It was really dark and quiet. I'd never seen anything like it. And I could see the light from the door anyway by then, so I knew where the door was.
The smoke forces Toff to abandon her search. Just minutes after pulling off the runway, British Air Tours Flight 28 has been consumed by fire.
We got out of a flight deck which was relatively intact, and when we turned round on the ground, we saw a complete wreck of an aircraft, and it had happened in a matter of seconds. It was dreadful.
54 people are dead. Another would die in hospital.
There was nothing wrong, really, with us. We thought nothing physical wrong with us. But our lives changed, you know, just in those few hours.
I couldn't breathe. I was virtually out the door, and I couldn't breathe then.
The smoke was coming in and everybody just stood up and ran out. It was just a mad panic getting out.
Because when the smoke came, you just couldn't see anything at all. Couldn't see anybody.
It takes 125 firefighters more than 2 hours to put out the fire. News of the disaster soon spreads around the world. British Prime Minister Margaret Thatcher flies to Manchester to visit the scene.
When we get a terrible air crash of this kind, everyone is appalled and shocked. Every single aspect of this accident will be thoroughly investigated. It has to be.
This is the 4th major commercial air disaster of the year. In June of 1985, an Air India jet exploded over the Atlantic Ocean. 329 people were killed. Weeks later, 137 people died when a Delta Airlines flight crashed at Dallas-Fort Worth Airport. And just 10 days before the Manchester crash, the deadliest single aircraft accident in history. Japan Airlines Flight 123, a fully loaded 747, slammed into a mountain, killing 520 people. British Air Tours Flight 28 adds 55 new victims to the list of casualties. 1985 is now the deadliest year in the history of commercial aviation. The flying public is getting nervous. Britain's Air Accidents Investigation Branch sends a team to Manchester to unravel the events that led to the catastrophe. Among them, Stephen Moss. He'll be inspecting the plane's engines.
This should not really have happened. The aircraft didn't even get airborne. It didn't run off the runway, and yet still 55 people were killed.
Chris Prothero is also on the team. His focus is on the fire.
We were aware from initial reports that the fire had entered the aircraft very rapidly as the aircraft came to a halt, and that was a focus for me.
It doesn't take too long for Stephen Moss to figure out where the trouble started. He sees damage to the plane that was not caused by fire.
Well, the first thing we noticed clearly was the hole in the underside of the wing. And right next to it was a gaping hole in the side of the engine. It seems that one had led to the other.
To get a plane loaded with passengers off the ground, you need to generate massive thrust. That power is created when air travels through the front of the engine to a series of compressor fans. It's then ignited, and the exhaust pushes the plane forward. Something had clearly gone very wrong with Flight 28's left engine. Investigators look for clues on the runway and in the cabin, hoping to discover why so many people died.
Entering the cabin for the first time, there was as with all aircraft fires, there's an overwhelming and pungent smell. Burning plastic, burnt fuel, burning material had dropped down onto seats, and so the aisles were filled up with the remains of overhead lockers. A scene of devastation.
The damage in the cabin is revealing. It's almost completely charred up high, but is relatively intact down low.
It was clear that there had not been flashover in this particular case.
A flashover occurs when the gases in an enclosed space become so hot that they ignite, incinerating everything around them. The way Flight 28's cabin is charred tells Prothero about the nature of the fire.
Many of the seat squab, cushions, even things like the emergency evacuation cards, which are just plastic laminated cards, were pretty much undamaged. You could have wiped them off and put them on another aircraft and nobody would have known they'd been in this accident, whereas at the upper levels in the fuselage, there was a great deal of heat damage, and this is not a characteristic of a flashover.
The fire in the cabin had been severe, but should not have been catastrophic. This leaves investigators with two questions. Why did so many people die? And what caused the fire? The answer to the second question may be outside the plane, lying on the runway. Investigators find a large piece of dome-shaped metal along the plane's path. Stephen Moss can see it's from a piece of the engine called a combustor can.
It looks like there'd been a separation of the can from the front end from the back end.
The combustion chamber of the 737's jet engines contains 9 combustor cans. It's where fuel and air are mixed and ignited, so each can needs to withstand intense heat. Moss suspects the fractured can somehow blew apart and destroyed the plane's left engine.
It had struck an underwing fuel tank access panel and put a sizable hole in that, which directly led to the release of a vast quantity of fuel.
Proving the piece of the combustion can penetrated the wing is easy. It fits neatly into the hole in the wing.
This was clearly, if you like, the root cause of the accident.
The engine on the plane is a Pratt & Whitney JT8D. For Moss, that's of grave concern.
At the time, was probably the most widely used jet engine on commercial air transport in the world. And it was obviously pretty urgent that we try and find the cause of this one in order to prevent other aircraft having the same problem.
There are tens of thousands of combustor cans in service around the world. One of them erupted in Manchester. Stephen Moss needs to find out why it failed. And fast. Investigators looking into the deadly fire on board British Air Tours Flight 28 study the plane's maintenance log. They discover the combustor can that ruptured had previously been repaired.
We needed to look at that repair and how effective it was.
During a routine inspection a year and a half earlier, mechanics had found small cracks in some of the combustor cans.
It was certainly not uncommon to find fatigue cracks in the cans. They're operating in a high-temperature environment. The manuals give various schemes for repairing these cracks.
Investigators find mechanics repaired the cracks according to a procedure laid out in the engine repair manual. They welded them closed. But the crack on can number 9 was unusually long.
The overhaul manual did not give any limit on the length of crack that could be repaired, and it was a longer crack than had been experienced before. It was still repaired.
After the repaired cans were put back in the engine, mechanics had no way of knowing the weld didn't effectively seal the crack. That's because the cans can't be inspected while the engine is on the plane. Since the repair, there were 11 reports of slow acceleration from the engine that exploded in Manchester. A damaged combustor can could have been a reason for the problem. But troubleshooting guides available to mechanics in Manchester didn't list that as a potential cause. Instead, Pratt & Whitney offered other ways to fix the acceleration problem.
It didn't seem to ring any great alarm bells with them, if you like. They'd seen it before, and it had never turned out to be anything serious.
So mechanics in Manchester made minor adjustments to fix the plane's idle speed and kept the plane in operation. Cockpit voice recordings revealed that the crew of Flight 28 was aware there was a problem with slow acceleration.
Slow acceleration on number 1 engine the day before yesterday.
I was on the flight, yes, sir.
Engineers signed off on it.
But the log entry led Captain Terrington to believe that the problem had been fixed.
A comment in the TET log for the flight before the last one, that the engine was slow in accelerating. It wasn't apparent as a serious problem because the engineers had done some work and the aircraft had been flying the previous day with no problems.
The idle speed adjustments didn't fix the real problem, the cracked combustor can. And it reached the breaking point on Flight 28.
Stopping. 28 Mike, we are abandoning takeoff.
Evacuate! Evacuate! Please stay calm and don't panic.
If the airline had inspected the cans, I think there is no doubt that they would have seen the problem.
Investigators now know the origins of the Manchester disaster. The welded crack in combustor can number 9 gave way as Flight 28 sped down the runway. The front of the can was ejected from the engine and put a hole in the underside of the left wing. That led to a huge fuel leak onto the damaged engine, which caused the fire. Engine fires are not uncommon. The body of a 737 is insulated with fire-retardant material to protect the cabin. Investigators still don't understand how a fire outside the plane spread into the cabin as quickly as it did. Fire Inspector Chris Prothero finds part of the answer from viewing photographs of the plane as it sped down the runway.
It was clear from these photographs that there was a very dynamic phase to the fire whilst the aircraft was at speed on the runway, which produced this energetic, turbulent, sort of blowtorching type of fire, visually anyway, trailing behind the aircraft.
A press photo from the day of the crash leads Prothero to a new theory.
The photographs of the aircraft that appeared in the press showed the left thrust reverser deployed. The general impression that one got visually from that photograph was that the thrust reversers had effectively blowtorched fire against the side of the fuselage, and that, if you like, was the explanation as to why the fire had penetrated so quickly. That photograph and the implications of it actually therefore loomed quite large.
Stop!
There are several ways to bring a speeding jetliner to a halt. One is with the brakes.
Don't hammer the brakes.
Another is with the engine's thrust reversers. Thrust reversers redirect the exhaust from the jet engine forwards. This helps slow the plane down.
It looked as though the thrust reversers had simply blown this big fire on the left of the aircraft directly onto the side of the aircraft, directly onto the rear fuselage.
That would explain why the fire destroyed the cabin so quickly. It now seems possible that Captain Terrington made the fire worse by trying to slow his plane down. But Prothero has two good reasons to doubt his theory. One is the location where charring from the burning exhaust gas, or efflux, was found.
The efflux impinges on the fuselage further up, closer to the roof, the crown skins of the aircraft. So actually, the penetration that we had low down did not fit with that.
And the other reason is, by the time the thrust reversers were deployed, the left engine had already exploded. But to act as a blowtorch, the engine would have needed considerable exhaust.
We did calculations to confirm that the residual thrust from that engine would not have had the energy to have this effect. That confirmed that the thrust reversers couldn't actually have played any role, or significant role anyway, in the fire's severity.
Clearly, something other than the thrusters had caused the fire to spread so quickly. Prothero looks more closely at the data. After examining weather reports from the day of the accident, he finds the answer.
The wind was the main factor that determined the severity of the fire in terms of its attack on the outside of the aircraft, how rapidly it penetrated the aircraft, and it also affected the conditions inside the cabin.
Believing he had blown a tire, Captain Terrington made a fateful decision.
Stopping. 28 Mike, we are abandoning takeoff.
Well, when we heard the thud and we closed the throttles, it was my assumption that we were going to turn off the runway, clear the runway, ask air traffic for an engineer to come out and check the tyres.
Like a highway, an airport runway has a series of exits. Captain Terrington chose one called Link Delta.
So we've got a fire on number 1.
When we got the additional information of a fire warning, the brain was already programmed to carry out the stop.
The crew had been aware that they had a fire, but didn't really appreciate at the time the nature of the fire, the severity of the fire, so they had turned off the runway.
Captain Terrington turned his plane to the right and brought it to a stop. He couldn't have realized that doing so would make the problem far worse.
There was a crosswind, a slight crosswind, from the left side of the aircraft that was carrying the fire that was burning from the fuel that was pulled underneath the left wing. It carried that fire aft, rearwards, and took over and under the rear fuselage, in between the wing and the tailplane.
The wind wrapped the fire around the back of the plane and into the cabin.
If there'd been no wind at all, I think the situation would have been very much more benign.
Investigators have discovered how the fire started and the conditions that caused it to penetrate the cabin. Now investigator Ed Trimble must solve the biggest mystery surrounding the Manchester accident.
Here we had an aircraft which had aborted the takeoff for good reason. It had taxied off and stopped in a taxiway in an expeditious manner, and yet 55 people had lost their lives. So there was a big question as to precisely why that had occurred.
Investigators learned that most of the dead were not found in the worst burned parts of the plane. Autopsies will point to the real killer on Flight 28. Of the 54 people who died in the cabin, only 6 had suffered serious burns. All the rest died from smoke inhalation. It seems the smoke in the cabin was particularly lethal. Survivors tell investigators that the smoke was unbearable.
The smoke was really black, and it was almost touching. It was really weird.
And they say the effect of that was shocking. Immediately you took one breath of the smoke, you began to feel debilitated, and you knew that if you took another breath or two, you weren't going to make it.
At the time of the Manchester accident, the effects of fire on an airplane had been well studied and understood, but the effects of smoke were not. To figure out what made the smoke so toxic, Trimble decides to recreate the fire that burned on Flight 28.
We were trying to model not only the gases which were produced, but also the kind of threat levels which were produced.
The smoke that filled the plane was from materials burning inside the cabin. The foam in the seats, the wool in the carpets, and the plastic overhead bins all release poisonous fumes. Those conditions are recreated by burning those same materials. Trimble discovers the passengers on Flight 28 inhaled smoke that contained a deadly blend of poisonous gases, including high levels of carbon monoxide and hydrogen cyanide. Now he desperately needs to find out if there's any way to protect airline passengers from that kind of smoke.
So it seemed to me pretty clear that unless we could protect people's respiratory systems from the assault from such combustion gases, there was little that we could do to improve survival chances from aircraft fires.
Over the course of 5 weeks, investigators run dozens of tests, experimenting with different filters. They burn nearly a quarter ton of material to create the necessary smoke. Their dramatic conclusion: it may have been possible to save passengers' lives.
There was not the slightest doubt in my mind that in these situations, in an aircraft cabin, if it is being assaulted by combustion gases, your chances of survival are vastly improved if you have smoke hood protection.
British Air Tours Flight 28 had only enough smoke hoods for the crew. They were never used. Trimble's research indicates that smoke hoods for passengers could have saved lives.
There were hoods available, both of the filter type and the breathable gas type, which can provide a very high level of protection to people in these circumstances.
Many of the passengers on Flight 28 would have survived with a few more minutes of breathing time.
It was in a blink of an eye, you know, from the time, you know, we stopped on the runway, you know, just within a few minutes, you know, it was all over, really.
A full Boeing 737 is designed to be evacuated in less than 2 minutes. So even without additional time, more of the passengers on Flight 28 should have been able to get off. To discover why so many people never made it off the plane, investigators turned to an unlikely source for the answer. By law, airplane manufacturers must prove their planes can be evacuated quickly and safely. When the 737 was introduced in the UK, Boeing demonstrated that 130 people could get off the plane in just 75 seconds.
All public transport aircraft are certificated to the same criteria, and that is that the total complement of passengers must be capable of evacuating from the aircraft using half the exits in the aircraft, it's generally one side or the other, within a maximum of 90 seconds.
But 90 seconds after Flight 28 came to a stop, most of the passengers were still on board.
The reason why the evacuation in Manchester wasn't achieved in 90 seconds is because the conditions in a real fire evacuation are completely different from the certification conditions.
The certification evacuation is conducted in clear conditions, with no smoke that reduces vision and overwhelms passengers. Within minutes of coming to a stop, Flight 28 filled with thick black smoke.
As soon as the smoke began to spill into the rear cabin and then flow forwards, essentially that induced immediate panic in those who were so affected by the smoke, because their respiration, I mean, the typical comment was, I took one breath of smoke and I felt as though my lungs were solidified. You can imagine under these conditions that people have got to get away from the smoke. And the people did this by basically clambering over the seats and other people in front of them.
In less than 5 minutes, what should have been a survivable accident turned deadly. To prevent future tragedies, Britain's Civil Aviation Authority decides to learn more about people. Helen Muir is a psychologist and a leading expert on how airplane design can influence survival. She's asked to study the behavior of passengers on Flight 28 to figure out why so many died.
What we had to learn to do was to design the aircraft interior so even if we had what we might say was dysfunctional behaviour in totality, we could accommodate the needs of individuals and their desperate rush to get out.
Muir configures a cabin to duplicate Flight 28 and fills it with volunteers. Then, to have them act as though the plane's on fire, she offers money to the first ones off.
And that produced behaviour that was quite unbelievable. People went over seats, they went round, past each other, all sorts of things. And indeed, when survivors from the actual Manchester accident came and saw the videos, they said, yeah, that's how it was.
The evacuation of Flight 28 was slowed by the fact that passengers became jammed in the bulkhead opening separating the main cabin from the galley. Investigators discover the logjam was created by the design of the Boeing 737. The bulkhead opening was 22.5 inches wide, just enough for one person to fit through.
But what they wanted to know was how much wider would they have to make it for people not to get stopped and blocked. We were trying to do as much as we could to recreate the situation which had happened at Manchester and then to systematically vary the aircraft interior to see what changes would improve the situation for passengers.
Muir's tests showed the narrow bulkhead opening created bottlenecks that flight attendants had to constantly clear. Increasing the width to 30 inches greatly improved the movement of passengers.
But we showed through repeat testing that if you changed the minimum gap from 20 to 30 inches, you would dramatically improve the speed at which people could get out and you'd reduce the likelihood of people falling and slipping and so on.
As a result of Helen Muir's work, a recommendation was made to increase the space between the bulkhead walls to 30 inches and introduce strip lighting to help guide passengers to exits even when they are blinded by smoke. Muir also found a way to improve cabin safety without redesigning the cabin.
Please sit down.
She conducted research on the behavior of the cabin crew in emergencies and found that passengers get off a plane much faster with a highly assertive crew.
It's because we don't want people really making their own decisions. We want people to do exactly what the cabin crew or the procedures state, and we don't want people hesitating, particularly at the door.
Helen Muir's research prompted manufacturers to redesign cabins to make them safer. But one safety feature remains controversial: smoke hoods. Ed Trimble believes they should be mandatory on all commercial flights.
Without a doubt. Without a doubt.
Helen Muir is less convinced. She's studied how smoke hoods affect passenger behavior and is worried they would slow down the orderly evacuation of an airplane.
We know you've only got literally 1.5 to 2 minutes for everybody to get out. What we don't want to have is something which is difficult to put on, and so it slows people getting down.
The most important lesson of British Air Tours Flight 28 is that seconds matter. It's now universally accepted that it takes 90 seconds from the first sign of fire before it becomes unsurvivable. The passengers on Flight 28 lost valuable time when the starboard side door jammed. The investigators determined that the slide mechanism deployed too early, preventing the door from opening. There was a flaw that led the slide container's lid to jam if the door is opened too quickly. After the Manchester accident, Boeing quickly redesigned the system so that couldn't happen. But the recommendations made by the AAIB weren't adopted quickly enough to save lives 6 years later. In 1991, a Boeing 737 slammed into another plane on the runway in Los Angeles and caught fire. Many of the 22 people who died were overcome by smoke before they could get out. But in 2005, the crash of an Air France jet in Toronto showed how much has changed since the Manchester accident. All 309 people got off that plane in just 90 seconds. No one died. Some major changes to commercial airliners
all right, the door's open.
came about because of a flight that never left the ground.
That's the only way I can resolve it, with the death of 55 of my passengers. The fact that flying is now safer.
I can't imagine anybody, you know, doesn't wish that it hadn't happened. You know, despite what's been learned and despite maybe the subsequent lives that have been changed, you know, you'd give anything for it not to have happened.
For investigators trying to solve a plane crash, the most important tool can be the black box. It records every detail in the cockpit.
Look at this. Where's Charlie at?
And tells investigators about vital conversations.
Damn, it's starting to rain.
Northwest 255, runway 3 center, clear for takeoff.
But in the crash of Northwest Airlines Flight 255...
I have never been to an accident of that scale.
It wasn't what investigators heard on the tape.
TCI was on set.
It was what they didn't hear.
It was checked.
That would lead to an astonishing conclusion. Detroit, Michigan, August the 16th, 1987. It's 8 p.m. and the city is sweltering. 25 kilometers from downtown, Detroit Metropolitan Airport is one of the busiest airports in the United States. More than 1,100 airplanes use its 4 runways each day. Today, one of those is Northwest Airlines Flight 255, bound for Phoenix, Arizona. Captain John Mouse is in command. A Las Vegas native, 57-year-old Mouse is a veteran pilot. His first officer is 35-year-old David Dodds of Galena, Illinois.
Why don't you tell him we're ready to go?
Both have years of experience on this type of aircraft. The MD-80 is also known as the Super 80 and is the second generation of the DC-9.
The MD-80 was quite a bit longer. It had more powerful engines, so it could carry more people. For that reason, it was a better moneymaker for the airlines than the DC-9 was.
Look at this.
The sky between Detroit and Phoenix is filled with storms. Several are moving quickly towards the airport.
There's a line here.
For the crew, it's been a long day.
They're about 25 miles wide. Well, if we get out of here pretty quick, we won't have a delay.
They've already flown from Minneapolis, Minnesota, to Saginaw, Michigan, and then Detroit. Phoenix is their next stop on the way to Santa Ana, California.
If we wait till after the storm's here, there'll be delays going over Waterville.
If they're delayed by weather, they may not make their final destination.
Let's get out of here before it starts raining.
The plane's 149 passengers are also eager to leave. Paula Sheehan and her family have been visiting relatives. They're heading home to Arizona. Her daughter Cecilia is only 4 years old.
Looks like bags are all in. Why don't you tell them we're ready to go? Ramp 255 and Delta 15.
Flight 255 is running half an hour late.
Northwest 255, cleared to go.
Okay, we're cleared to push.
Let's do the checklist.
Brakes.
Set.
Windshield heat. It's on. Push the pumps. Unit 6. Cabin pressure controller. Checked. Auxiliary hydraulic pumps and pressure. On and checked.
Yeah. It's starting to rain.
To beat the storms, they need to leave immediately.
Sign beacons. Go on. Before start checklist is complete.
Flight 255 begins moving from the gate to the runway.
Northwest 255.
But because of the weather...
Northwest 255, now exit at Charlie Runway 3 Center.
The ground controller gives them a last-minute runway change.
Okay, out to Charlie for 3 Center, Northwest 255. Charlie for 3 Center, right.
Okay.
Ladies and gentlemen, we're currently number 1 for departure. We should be rolling in a couple minutes. Let attendants be seated. Thank you.
Blacker than hell out there.
Where's Charlie at?
By the time they get to the new runway, they're 45 minutes behind schedule.
Northwest 255, runway 3 Center, clear for takeoff.
Within 17 seconds, 65,000 kilograms of passengers and aircraft hurtle down runway 3C. But moments before liftoff, Mouse discovers he can't engage the auto throttle.
We'll stay on. TCI's on set.
His computer isn't in takeoff mode.
They're on now.
Okay.
Clamp. 100 knots.
At 313 kilometers per hour.
V1. Rotate.
The pilots angle the plane's nose up for liftoff. Then something else goes wrong. Just under 50 feet from the ground, the aircraft begins rolling from side to side.
Power lifeguard copter 102.
It rolls left and strikes a light pole. Out of control, Flight 255 slams into the ground, skids along a highway, and disintegrates when it hits an overpass.
I prayed that everybody made it, but I thought it was just a small plane because it happened so quickly. I didn't know it was a bigger plane, and it was just awful.
Saw the plane come through the viaducts, a big fireball.
Well, we got dispatched. It was a rainy Sunday night. And
And then he said there's an airliner down, and our mood kind of just changed. And the one guy looked at me, Dan, and said, well, I hope it's a small one. When we pulled up, we saw the cockpit and the word West written on the fuselage, and we looked at each other, and he said, it looks like a big one.
There's a trail of scorched bodies and debris more than a kilometer long. Just minutes after impact, paramedic Tim Schroeder is on the scene looking for survivors.
I have never been to an accident of that scale. We were struck by the magnitude of what we were seeing, the large scale of it. It was almost overwhelming.
From the little that's left of Flight 255, it is unlikely they'll find anyone alive.
And I buddied up with Dan, and we both started entering the wreckage. It was probably a minute went by, and Dan actually heard a noise. He asked me a couple times, do I hear anything? And I said no. And then finally I heard it, and it was more like a faint cry. When I turned my head to the right, I saw an arm underneath the seat. 1, 2, 3, lift! She was covered in some blood and some soot.
Somehow, 4-year-old Cecilia Sheehan has survived the crash. But she's badly injured. Tim Schroeder races her to hospital.
We have a 4-year-old girl found alive in the wreckage. She has a very weak pulse.
If Cecilia survived, perhaps others have as well. Rescuers spend hours looking through the wreckage for more survivors, but their efforts will be in vain.
We actually covered anything that was a body or a body part with a yellow blanket. It was just nothing but like a sea of yellow blankets, basically.
Northwest Airlines said 154 passengers and crew aboard the plane died in the crash.
Both Captain Mouse and First Officer Dodds are killed in the crash. 2 other people died when their cars were hit by the plane. This is the second deadliest airplane disaster in US history. Recovering in hospital with serious head wounds is Flight 255's lone survivor, 4-year-old Cecilia Sheehan. Despite her injuries, doctors say she will live.
Maybe God was on her side that night.
Within hours of the crash, investigator Jack Drake and his team from the National Transportation Safety Board begin looking for clues. Drake is a former Navy pilot who's been involved in hundreds of crash investigations.
You know when you're at a crash site because you get this combination of burned plastic and kerosene, and sometimes combined with fire retardant foam that has its own distinctive odor. You know you've arrived when you smell it.
Drake and his team treat the crash site like a crime scene.
Our team consisted of 12 or 13 specialists, some of whom go to the site and some of whom do their work elsewhere.
They set out to examine every piece of wreckage to discover what went wrong.
They have responsibilities for looking at different parts of the wreckage debris and do qualitative analysis of those parts. We always look for the recorders first. They're frequently referred to as black boxes, although they're usually orange. The information is usually well protected because they're encased in a steel box that is both heat resistant and crash resistant.
Since the 1960s, commercial jetliners have been required to carry flight data and voice recorders. The CVR was first introduced in Australia following the 1960 crash of a Fokker F-27. The devices must be able to withstand an impact of 3,400 Gs and temperatures as high as 1,100 degrees Celsius. The cockpit voice recorder is intact, but the flight data recorder suffered some damage in the crash. They may hold the only clues that can help solve this accident. Both recorders are sent to the NTSB lab in Washington, D.C. John Clark is Drake's flight performance engineer. His first task is to make a map of the debris left behind by Flight 255.
When I first started seeing the wreckage, your mind immediately starts turning to sorting out where it hit, how it hit, not where the wreckage ended up, but those first few inches where the airplane was coming down.
Clark looks for ground scars and other impact marks, and interviews witnesses to piece together where the plane fell and how.
And that kind of gives you a sense of those last moments, what the airplane was doing when it hit the ground.
Clark begins to understand the final moments of Flight 255. According to witnesses, as it lifted off, it couldn't climb and flew in a nose-high position.
B1, rotate.
That could indicate that the plane didn't have enough power to get off the ground, that it didn't have enough speed, or that high winds prevented it from lifting off. Witnesses provide investigators with a critical clue.
You saw fire coming from the engine.
Several, including an air traffic controller, saw flames coming from the plane's engine before the crash.
Damn.
The engines become the first focus of this investigation.
They look for evidence of an internal failure.
The plane suffered an engine failure.
Investigators soon learned that less than a month earlier, one of the plane's engines was damaged when it was hit by a foreign object. It was repaired and was being monitored by mechanics to see how it performed. The team studies the remains of the engine for clues that it had either caught fire or shut down on takeoff. Despite what the witnesses saw, they find no evidence of fire or of a massive breakdown.
The information suggested that the engine operation had been normal.
Plan, 100 knots.
The flames were the result of the fuel tank rupturing after the plane hit a light pole. The fire didn't cause the crash. If Drake and his team are to solve this mystery, they need to be certain about what happened in the last few seconds before Flight 255 crashed.
Well, I think probably the best physical evidence is what was on the flight data recorder. The flight data recorder doesn't tell you about weather, it tells you about aircraft parameters, aircraft performance essentially, second by second, even at quarter-second intervals in some parameters.
But NTSB technicians can't recover all the information from the recorder. They send it to the manufacturer to see if they can recover the lost data. While he waits for news about the flight data recorder, Jack Drake looks more closely at the weather on the night of the crash.
There was some convective or thundershower type activity that had moved through the area, and its impact on the accident required a lot of analysis.
Drake wonders how the storm affected Flight 255. He listens to the cockpit voice recorder for clues. He discovers the menacing weather was a concern to the crew.
Let's get out of here before it starts raining.
Jesus, look at this.
Drake sees that there were several storms along the flight path, and they were getting closer to Detroit.
There's a line here, and a line between these two, and another one here about 25 miles wide.
Thunderstorms can create a very dangerous threat to pilots.
Since there was severe weather in the area, we always worry about microbursts.
Microbursts occur when columns of air shoot down to Earth. As a plane passes through, winds batter it from all directions, making it difficult to control.
In a microburst condition, you can get very shifting winds and also vertical winds that try to push the airplane into the ground. So you can get loss of airspeed, a very rapid rise in airspeed, and then also actually push the airplane toward the ground. And it requires very aggressive flying on the part of the flight crew.
This unusual weather condition had killed before. In 1985, a microburst brought down a Delta Airlines flight in Dallas, killing 137 people. At the time of the Detroit accident, there was no device at airports to accurately detect microbursts. Instead, pilots relied on reports from other crews. Jack Drake discovers that 27 minutes before liftoff, Captain Mouse and First Officer Dodds received such a warning.
Ground, this is 722. You just had a microburst out here. The dust just exploded down there.
Investigators suspect that a microburst may have slammed Flight 255 to the ground as it tried to lift off.
It was right after departure when the accident occurred. If they had struck a very strong microburst, that would be a candidate for one of the possible causes.
Satellite images taken at the time of the crash and weather data from the airport's sensors show that there were storms near the airport at the time of the accident. But there's no evidence of a microburst.
Wind and rain, but nothing that could be a microburst.
Around the time of the crash, the airport's sensors did record a dangerous gust of wind on the runway, powerful enough to set off alarms in the tower. Upon further investigation, Drake discovers that Flight 255 was still at the gate at the time of that alarm. So the winds couldn't have brought the plane down.
Sign beacons.
But they did have a huge effect on Captain Mouse's flight plan. The crew's pre-flight dispatch package stated that they would take off from runway 21 left. But with the sudden change of wind direction, ground control sends Flight 255 to runway 3C, the shortest of 3 available runways.
Northwest 255, now exit at Charlie runway 3 center.
Okay, out to Charlie for 3 center, Northwest 255. Charlie for 3 center right.
Okay.
Controllers try to have planes take off into the wind. The additional wind flowing over a plane's wings gives it more lift and helps it get off the ground. Taking off into the wind is safer, but taking off on the shorter runway now means First Officer Dodds must recalculate the plane's takeoff weight.
There's a runway change. You have to determine if the weight of the aircraft will permit it to accelerate and climb out safely. And this varies depending on the length of the runway, temperature, altitude of the airport.
Perhaps First Officer Dodds made a mistake in his calculation.
44.4. How can we be that light for a full airplane?
If he did, it could explain why the MD-80 wasn't able to make it off the ground. Runway 3C simply wasn't long enough. Using calculations based on average weight of luggage and passengers on board, Drake's team confirmed Dodd's estimate. The plane weighed 144,047 pounds, well below the allowable limit for runway 3C. It should have been able to get off the ground. Drake's investigation has hit another dead end. He and his team are running out of possibilities. Until technicians can decode the damaged flight data recorder, the team must rely on the physical evidence that's been found at the crash site. But when investigators study the cockpit's center console, they're forced to consider an almost unimaginable cause.
Is this the way it was found?
To get the plane off the ground, the flaps on the wings should have been extended to the 11-degree position. But the way the flap handle is damaged suggests the plane's flaps were retracted when it crashed.
The pin had left a mark. This happens because the aircraft comes to a very sudden stop and the handle jangles around, and it's a metal-to-metal contact that's exaggerated by the impact.
Well, stay on.
That indicator was that the flaps were zero or fully retracted and the slats were retracted as well.
Flaps and slats are extensions that slide out of the back and front of the wing. They make the wing bigger, which increases the amount of lift they can provide. They must be extended for takeoff.
If the slats are retracted, and for the most part, with today's modern jets, the airplane is not capable of flight. It's not capable of flight.
If the crew tried to take off with the flaps retracted, it would be an astonishing blunder.
B1, rotate.
But a pilot who was lined up directly behind Flight 255 on the runway is certain the plane's flaps were extended.
And you're sure the flaps were extended?
Pilots in other aircraft that were close to the point where the takeoff had begun were telling us that they thought the flaps and slats were deployed to a normal position.
Investigators can't be sure whether the flaps were extended or not. The clues they need lie somewhere in the sea of debris recovered from the crash site. Eventually, investigators find the evidence they need inside a section of the plane's left wing.
Each component of the slat system has its own drive system, and one of those was interrupted by the light pole that passed through the wing. 18 feet of the left wing was severed.
The cable controlling the slats was sliced in two when the wing hit the light pole. Based on where the cable was cut, investigators can tell whether the slats and flaps were extended or retracted.
It severed two cables, and if you lined up those two severed ends, it corresponded with the slats being in the full retracted position.
It looks increasingly likely that the crew never extended their flaps. Only the damaged flight data recorder can verify this. Fortunately, technicians have finally been able to rescue all its data. A digital history of Flight 255's performance until the moment of impact.
I knew that if we had a good recorder, we were going to get data back. The flight data recorders in combination give you that time history that goes together with the physical evidence or physical damage.
As expected, the FDR confirms what the evidence has been showing investigators.
Flight data recorders told us that the flaps and slats had not been extended.
It's a major breakthrough. Drake now knows what brought down Flight 255. But the flight data recorder doesn't answer a more troubling question.
So, why weren't the flaps deployed?
For some reason, a seasoned crew forgot one of the most basic steps involved in getting an airplane off the ground. Two months after the crash, Northwest Airlines Flight 255's sole survivor, Cecilia Sheehan, is released from hospital.
We can't be sure why the little girl survived. She's a very little girl buckled into a big seat. and she was more protected than adults that might have been sitting around her. But she was very lucky.
Jack Drake needs to know what contributed to the death of her family and all the other victims. He finds an important clue on the cockpit voice recorder. It shows that the last-minute runway change caused confusion in the cockpit.
Once the aircraft began to taxi,
blacker than hell out there.
Northwest 255, now exit at Charlie Runway 3 Center.
other activities were introduced that had the potential to cause distractions.
Did he say 3 Center?
3 Center, yeah, that's why I was thinking we had to go that way.
I was thinking 2-1.
Well, they made a wrong turn, which might have been confusing because they had to go a different route.
Where's Charlie at?
Right at the end of this ramp.
I think Charlie was...
No, it is Charlie.
You sure?
I think so.
The crew got lost on the way to runway 3C.
Ground, Northwest 255. I guess we went by Charlie. We're going to 3 Center right.
Northwest 255, affirmative. Make a left turn at Foxtrot.
They finally got to the runway 45 minutes late.
Ladies and gentlemen, we're currently number 1 for departure. Should be rolling in a couple of minutes. Flight attendants, be seated. Thank you.
But Jack Drake finds something missing on the CVR. It seems the crew overlooked a very important step.
We're okay for the center runway, aren't we?
Before they got lost, the crew of Flight 255 performed a number of checklists. But possibly due to the confusion of the runway change, they seem to have completely neglected the taxi checklist.
They apparently didn't consider the checklist, and key in the checklist is the configuration of the aircraft for departure, and the flight data recorder showed that was never done.
There are hundreds of small steps for a crew to take to get a passenger jet off the ground. Most of them are covered by checklists.
The checklist is a means by which you ensure that important items are positioned or done properly.
Transponder.
Instead of doing it by memory and having the possibility of a lapse of memory.
Brakes.
Flight crews use a very rigorous and regimented procedure of following the checklist. Verify that each switch, each dial, each lever is in the proper position before taking the runway for departure.
The first item on the taxi checklist is flaps.
One of the things that would have been included in their checklist was to configure the slats and flaps for low-speed flight.
But because they didn't run the checklist, the crew never set their flaps to the takeoff position.
I think Charlie was...
No, it is Charlie.
You sure?
I think so.
They hadn't done this checklist at the time they normally would, and as the activities piled up that were potential distractions, they were further and further away from the point at which they would normally perform that function. Their mindset was probably that they had completed it.
The pilots got an indication that their plane wasn't properly configured. During takeoff, they couldn't activate the auto throttle because their computer wasn't in takeoff mode. Another step covered by the taxi checklist.
Won't stay on. TCI's on set.
This should have alerted them that they didn't perform the checklist.
If it had occurred to them at that point that we might have missed something else on the checklist, that could have led to a rejected takeoff.
They're on now. 100 knots.
Okay.
Apparently that didn't happen, and so the takeoff was continued.
With disastrous results. An alarm should have sounded when the pilots tried to take off with their flaps retracted. But for some reason, investigators can't hear it on the cockpit voice recorder.
When it activates, it alerts the crew that the aircraft is not in a configuration that's safe for takeoff.
Maybe it went off, or we just can't hear it.
The investigation team is determined to find out why the takeoff warning didn't sound. Technicians analyze the cockpit voice recorder for more clues, and they find something unusual.
They picked up some enunciations on the CVR that were not correct.
Stall. Stall.
This warning is alerting the crew that the plane is about to stall. But it should be coming from 2 speakers in the cockpit.
Stall.
Technicians notice it's only coming from 1.
Stall. Stall.
As the airplane lifted off, there was a stall warning, and it has a typical characteristic of a sound like stall all, because there are 2 enunciations, and the purpose of that is to provide redundancy. But that redundancy wasn't there. We had a single stall. I went to an MD-80 sitting on the ramp at Detroit, and a captain took us through the process of checking out to demonstrate those different sounds.
Let's start with the config warning.
The takeoff configuration warning is what would have alerted them about the flaps and slats.
Flaps. Slats. Flaps.
Can we get the stall warning to sound?
Stall all. Stall all.
He activated the stall warning system by a test switch, and it said stall all.
The voice on the left channel is slightly different from the voice on the right, as it should be. But that's not what Clark heard on Flight 255's voice recorder.
Can you make it sound like this?
Stall. Stall.
To get a singular stall, he had to pull power to one side or the other. And one way he demonstrated that is he pulled the P40 circuit breaker.
A circuit breaker is the electrical switch that protects the circuit from damage caused by overload. The P40 circuit breaker is an important one in this investigation. It handled both the failed takeoff warning and the stall warning systems.
What struck me was, he said, I hear people doing it. I, of course, don't do it myself, but let me show you how. And he reached around behind him, around behind the seat and down low and pulled the P40 circuit breaker without looking. And then when he ran the stall warning system, we got the singular stall.
Stall. Stall.
It's a major clue. Clark could only reproduce the strange-sounding stall warning by pulling the same circuit breaker that's connected to the takeoff warning. This tells investigators that the breaker was tripped when Flight 255 tried to take off. Then John Clark notices something else about the P40 circuit breaker.
You could see smudge marks around the decals on each side of the circuit breaker. It looked like finger marks where oil had built up and dirt and grime over the years. So it told me that that circuit breaker was being used routinely by a lot of pilots.
Can you tell me why that is so worn?
It turned out that the takeoff configuration warning could be a nuisance to pilots.
If you're doing a single engine taxi, you have to push the throttle up further to get a power to taxi, and you'd set off the takeoff warning system. And so they would pull the circuit breaker to silence it. It's irritating. It's a warning. It's meant to alert you. And if it's going off routinely all the time, it gets on their nerves. And so apparently pilots were routinely silencing those takeoff warnings.
Investigators suspect that the crew of Flight 255 tripped the breaker to avoid the irritating takeoff warning. And then, with the added delay from the runway change and the impending storm, they proceeded to take off without doing the taxi checklist. That might explain why the alarm didn't sound when they tried to take off with their flaps retracted.
We don't know if the pilot did pull that circuit breaker on that particular flight. There was certainly one error and the potential for two. I think that the extensive use of the circuit breaker because of the smudge marks around the circuit breaker and the pilot's statements, I think it's highly likely that he did.
It appears the downing of Flight 255 was caused by pilot error. Now investigators can accurately piece together what happened that night in Detroit. But it would take another shocking accident for the airline industry to learn its lesson. Jack Drake's team has discovered what caused the crash of Flight 255, but cannot prevent it from happening again. 1 year later in Dallas, Delta Flight 1141 tried to take off without their flaps extended. The investigators who had been working on the Northwest crash are stunned.
I was very frustrated to learn that another airline had done the same thing in a different aircraft type about a year later.
The Delta crash would uncover potentially deadly flaws
Before start checklist, battery.
in the checklists commercial pilots are trained to follow. The Delta and Northwest crashes killed 170 people and had eerily similar causes. In both disasters, the workload in the cockpit increased.
Jesus, look at this.
Northwest 255 now exited Charlie Runway 37.
If we get out of here pretty quick, we won't have a delay. Auto land.
And in both, the pilots failed to perform vital elements of their checklists.
It is very unusual for a crew to not perform a checklist. They have done it hundreds upon hundreds of times.
Brakes, windshield heat is on, cabin pressure controller is checked.
The normal procedures were a little bit out of the norm, and as a result, it got overlooked.
To prevent this from happening again, aviation officials turned to a government agency that knows the importance of clear procedures.
4, 3, 2, 1.
NASA.
So they're in there, ready to go. All right.
Jack Drake and his team wanted the US Space Agency to help create checklists that decrease the odds of items being skipped. Asaf Degani was a research scientist working with NASA. After the accident, he took on the project of improving a flight crew's pre-takeoff procedure.
We looked for any research that was done on checklists or procedures in general, and in fact, we couldn't find anything.
So Degani had to start from scratch. But there are dozens of different checklists to examine. Most of the ones on Flight 255 were printed on a single card. They listed the tasks the crew had to carry out, but didn't give them a way to keep track of what was and what wasn't done. At the time of the Northwest crash, there were several types of mechanical checklists in use. The US Air Force used a scrolling checklist. Once a checklist item is completed, the pilot scrolls to the next one. American Airlines used a system that allowed pilots to cover up completed items with a plastic slide, so only the non-completed items would be displayed. Asaf Degani set out to see firsthand how pilots were using checklists. He wanted to make it less likely for them to make mistakes. He sat in cockpits and observed 42 different crews in action. Degani concluded that many checklists were badly designed.
There's a certain flow by which you go about checking things, and the idea is to prevent a case where you're doing one thing here, one thing there. Checklist should have a certain flow, which is a logical flow, and not one which is kind of random. Go, and they're ready, and they're going through there.
Degani also found a much more serious problem with checklists. If pilots are interrupted, they sometimes forget where they left off.
Transponder checked, and
on.
And there's many cases where people would do A, B, C, D, E, an air traffic call would come, they'd have to respond to it, and that's an interrupt.
Northwest 255, now exited Charlie Runway 3 Center.
They would go back to the checklist and skip a certain item and continue on the list, assuming that the whole list was done. People were very concerned about that.
To ensure no steps are missed, airlines train their pilots to return to the top of a checklist following the interruption and start over. Again, Asaf Degani sees a problem.
And we found that if checklists are very, very long and meticulous, that's overburdening the crew, and they sometimes would not want to start again from the beginning.
To address the problem, Degani suggests changes across the airline industry.
One of our recommendations from the study is to try to take long checklists and chunk them to small pieces so that if an interruption happens, then doing another 4 or 5 items, it's not a big effort as opposed to doing 20.
Degani even made recommendations about the typeface that airlines use, so they can be more easily read by pilots. Perhaps the biggest advance to checklists is the move from paper to computers.
Since at the time computer technology was coming into the cockpit, it made a lot of sense to think about the electronic checklist.
Today, Degani and his team are studying smart checklists that keep track of checked items. They provide pilots with a visual indication of where they are on the list, and in some cases verify that the task has been correctly carried out.
Electronic checklist shows you which item was completed and which item was not.
Computerized checklists are now slowly making their way into the cockpits of commercial airplanes. They make it far less likely that an accident like Northwest 255 could happen again. The FAA also ordered a modification to the alarm system of all commercial jetliners to prevent nuisance alarms. The takeoff warning was redesigned so it could not sound unless the plane was actually taking off. Jack Drake went on to investigate hundreds of accidents over a 26-year career with the NTSB. The crash of Flight 255 taught him a valuable lesson.
This one is a worldwide example of the importance of following checklists and configuration being completed correctly on every takeoff. And so it became something that was a part of the training curriculum in virtually every airline around the world.
The case of Northwest 255 is no different. It's a series of events, runway change, task saturation, an overlooked checklist, a failed takeoff warning system. Put all of those together, those links in a chain, and you end up with the accident. If you were to break any one of those links, the accident wouldn't have happened.
Flight 255 will also be remembered for its lone survivor, Cecilia Sheehan. She's never spoken publicly about the death of her family. But she's stayed in touch with the people who rescued her that day.
She's full of life, and the conversations we have, it's more about, her sports and her husband and her vacations. She just said maybe one day she'll come out and tell the world what Cecilia is doing.